Tony, we'll go ahead and dive in, my friend, and begin. So, first of all, thank you everybody for hanging in here. Tony is traveling, but he wanted to do this great favor for us to host this conversation. So, um, our session, data to decisions, making AI analytics actually actionable. Tony's actually a longtime friend of mine, a longtime friend of my show, and is just a true expert in AI, all things GPUs, CPUs, APUs, but also really seeing AI in action, not just here in America, but also globally. So bringing all those best practices here, we always have great conversations. So let's go ahead and dive in. Kind of setting the stage a little bit, the gap between hype and reality. So, Tony, we've all watched AI go from pilot projects to the boardroom and seemingly overnight. From where you sit at AMD, working with health systems like science companies, and even AI developers every day, what's the biggest gap between what healthcare organizations think AI will do for them and what's actually happening on the ground today?
Well, that's a great question. There's actually a lot to unpack in that, believe it or not. So if we just look at the numbers, so in the last 3 years, there's been almost a feverish adoption of buying GPUs with the idea that this is somehow going to transform operationally and bringing automation to drive down cost. And that's still the goal that most organizations have. But between wanting that to happen and having that happen are two different things, unfortunately. So in talking to different leaders, and it came up this morning in the meeting I was at, there's a 77% adoption of AI, at least as a science experiment, in most healthcare companies. And when I say healthcare, I'm actually grouping life science and hospitals in this umbrella. But that 77% number is dwarfed by the less than 20% number that actually goes into production. And I think the gist of your question is, why is that?
Right.
Typically, it's this. So when healthcare has adopted a technology, they think of it in the same way they think of buying a new storage platform or a new compute platform, where they simply retrofit it in to the existing workflow and expect it to make that workflow better. This is not the case here, because it fundamentally transforms not just the speed of the technology, not just the ability to process faster, but fundamentally how the people in process integrate into this new model. And I don't think that was fully understood. It's getting better now, but it wasn't fully understood going forward. And I can think of an example. I was in Raleigh, North Carolina, about a month or so ago, in very large institution. You can probably guess who that would be. Ran into this issue, and they decided to come up with a really creative way of handling that, of going into production faster. They created a lab environment, a simulation of all the different workflows, and this could encompass medical imaging, this could encompass pharmacy, etc. And they gained out all the changes that would accrue by having automation from AI embedded into that workflow, and then made the adjustments before it went in production, so that when they actually adopted this, they already knew where the benefits were. They already knew where the changes had to be made on the process side and on the people side. And then, frankly, that's the advice I give everybody. And it's resonating. It's just not easy to do. But if you're going to make the maximum return on an investment in an AI platform, this has to be done. It has to be understood.
Yep.
It's a bit long-winded.
No, it's excellent. I completely agree. And Carol, you can hear this okay? And the audience can hear this okay?
Yep. Great workaround.
Excellent. Great. Thank you. Perfect. All right. Well, I do want to keep moving here. No, great. And we're going to dive into the ROI here in a minute as well. But this is fantastic, Tony. So when we talk about the hardware foundation, there's a lot of conversation around models, algorithms, and data, but not enough about it's actually running underneath it all. I know this is near and dear in your world, Tony. So how much does compute architecture matter when a health system's trying to move from an AI proof of concept to something that's actually deployed at scale and producing real decisions?
This is one of the notes from it.
Yep.
So there's talk these days, and I've run across this a bunch of times in the last 2 weeks, actually. where the idea is you don't need CPUs anymore. You just simply get GPUs and it'll do everything that you need. Nonsensical, in my opinion. Number one, the cost. GPUs are quite expensive. And what they're good at is the training side of the equation, being the bucket that allows all the material, all the information with regards to a model that contains medical imaging, for example, or billing or something else, to be able to train those models so that you can then develop the use cases against that. What it doesn't do exceptionally well is the inferencing side of this. And frankly, at AMD, we're pretty much focused on the fact that the inferencing side is where the growth of this is going to be, because that really is the brains of what AI as an entity is how it works. Is the inferencing that comes out of that to be able to create the level of automation that's required, and frankly, to lower long-term costs, because that's what this is all about. Ultimately, AI is a mechanism for lowering costs. So it's that balance between CPU and GPU in these hybrid environments, and tweaking those for the right level of hybrid performance, that's going to make the differentiation in success and failure. And low latency, high throughput, cost efficiency at scale, all of this have to be taken into account between both. I know plenty of startup ISVs that use a CPU alone, because in some cases it's far more efficient than using a GPU at a certain threshold. But as these models grow, it becomes a necessity to incorporate both. And I think anyone who's done any level of work in integrating these AI models will tell you the same. So infrastructure choices will determine whether you're going to get real-time insights or delayed reports. Okay, it's the difference between using Claude effectively or treating Claude like a 3-year-old toddler, basically.
Great point. So as a follow-up there, we do talk about CPUs, GPUs, even APUs sometimes, but we're in CPUs and GPUs, the right tool for the right job. Help our audience understand this practically. What does a healthcare AI workload actually need a GPU versus a high-performance CPU? And are organizations getting this wrong in ways that are costing them time or money, or both?
Yeah, basically, if the foundational computer isn't designed to scale, AI just stays in the science project. So, and that tends to be the same. And the threshold is variable, to be honest. A billion factors or a billion variables is easily handled by a CPU. And the rule of thumb is 7 billion and above, you start have to incorporating a GPU into the mix. That's a loose equation. It really depends on what you're trying to do. So I do know some protein analysis ISPs that are looking for patterns in different proteins, that are looking for modeling of antibodies. Using CPU only.
Right.
And they're putting out fantastic work in that regard. As the model widens, and then typically what happens in these things is that a use case is narrowly defined and then expands in scope over time. So if you're looking at different billing models in a hospital, for example, within the parameters of that institution, you could probably just use a CPU. But as you start expanding into the partnerships with the payer side, it becomes more complex. The integration becomes more complex. And then the different learning buckets that accrue from that require the extension to the GPU, to large GPUs to be able to do that. And at that point, this becomes an art more than science in being able to determine what the balance is. And that requires, number one, staff to be able to do that. And two, the commitment to making it work. Again, if you don't do that, then it just stays as a science project. It won't be designed for scale.
So, a quick follow-up on that, just for our audiences, mainly health systems, hospitals and health systems, and it goes back to the use case, but is there a direction that someone would start? Obviously, again, define your use case and the data and how much and what processing power you may need, but is there a best practice or a benchmark or a bench line that you would give as a recommendation? Be CPU versus GPU?
Because again, it depends on the use case.
Hmm.
It's very difficult to measure. Um, but there's white papers that we put out, and for anyone to ask, I'll be happy
Yep.
to send these out. But it's really dependent on the use case.
Okay.
And frankly, it's this. So if we think of the EMR as the nexus for all patient information, which in fact it's grown into, a lot of the different workload models are now embedded into that EMR. And so it becomes not a question of that individual workload, but the totality of the different workloads that are being managed by the different agents that determine what the infrastructure is going to look like.
Excellent point.
And that's different. And that's different if you're looking at a digital doorway project, or if you're looking at a clinical project that's geared toward physicians.
Yep.
Or clinicians versus support.
Yep.
It's all going to be different. But the key here is the adoption of this, at least in the hospital, is really going to be determined by what's available within the electronic health record system or the EMR.
Makes sense. Excellent. So next question, you and I talk about this a lot over the last couple of years, data quality. We both know that the most sophisticated hardware in the world can't fix bad data. In your experience working with healthcare and life science organizations, how often is data readiness, not the AI model itself, the thing that's actually blocking actionable analytics?
Great question. It's like 70% of the challenge. So, and again, I'll go back to medical imaging as an example. So, my background going back almost 30 years was around medical imaging, and I had always worked under the assumption that if something's got a DICOM tag, that those are accurate, and as it's archived, that we can use that to be able to build out different AI models for image analysis. It turns out not to be the case. In fact, the variance is so wide that less than 10% of the available medical imaging is AI ready to be used. And so we've had to put an intermediary step in between and actually look at the image itself. Forget the tagging that's on there. Forget the DICOM tagging. Look at the image itself. Create a new structure outside of that in order to be able to then use that archive of images to be used with AI. And that's been one of the biggest surprises over the last year, is the quality of the lack of quality of data that exists.
Right.
So long before you can determine whether AI is going to be successful or not, you got to look at the condition of the data. Is it in a metadata rich state that can be used? And if not, what are the steps necessary to get it to that? And I know it increases the overall scope of the project, but if you don't do that, it will not be successful. Again, you're going to look at a science experiment for a limited scope rather than production.
Excellent. Excellent.
This is where, and to go back to the previous question, this is where the training models with GPU become really critical, because this is geared exactly for that.
Yep. Nope. Great point. And I can kind of carrying on here, and this is a little bit on the imaging, genomics, and the compute intensive frontier. You guys AMD plays heavy in that area, certainly medical imaging and genomics. Walk us through what's happening at that intersection. I know we have that think tank, actually life sciences think tank next week. So this may be more for some of the research in the academic medical centers. But what are you seeing at the most meaningful clinical outcomes exchange between high performance computing right now and where these clinical outcomes are going?
Yeah, so it's a great question. So that you actually asked a bunch of different questions in that one question.
Yeah.
So sequential analysis, which is what genomics is. Okay, so sequential reads of a full genome. That's fairly easy to calculate, because it's single format coming through, and so a CPU, a single CPU, handled that quite well. If you're trying to then compare something like that with proteomics, where you're looking at the different reference models that come out of folding proteins, or looking at patterns, or an interesting case I saw recently, creating an agentic model that lets you model in silico what if scenarios. Okay, if I take the different factors from protein folding, from patterns that are noticed, and if we were to manipulate this, what kind of molecule can be identified for drug discovery? And frankly, this one area, this drug discovery area, is where vast amounts of investment are going into right now, and in fact requires the largest amount of compute. So in our event coming up, that's going to be the focus. Exactly how do we use the appropriate amount of compute power, and by this I don't mean just CPU, but a hybrid environment, to be able to accelerate both the learning model and the inferencing model to determine in silico modeling, digital twin, if you will, on what the next molecule can be for a particular set of factors.
Yep, I love it. Exciting. No, this is I love what we're doing, and obviously you guys are out in front of this. So you also now you keep bringing up some great positioning for me. So I love the hybrid, the cloud discussion here on-prem. I know where you are today. It's kind of cool to see some of the stuff come to maturation. So there's a lot of pressure on health systems to go cloud, quote unquote. But for a lot of reasons, latency, data sovereignty, cost, it's not always the right answer for AI inference workloads. What deployment architecture are you seeing actually work in production environments today?
Yeah, this is an old model, guys. I mean, it seems new, but this was the same argument when cloud was first available to IT some years ago. Is cloud was going to solve everything. Let's just move everything to the cloud, and then reasons of cost and reasons of control made that non-optimal. And so some compute came back. And the question became, well, what is it that should remain under our control in our own data centers versus what can we consume in the cloud? And that's exactly the same argument that's being had right now.
Right.
So where do you consume AI? And it depends. So the strength of the cloud is elasticity in training large models because the data is there. Okay. But the strength on site in the data center is the low latency. And for clinical decisions, this is critical. And then there's a whole question of data sovereignty, especially on the life sciences side in drug discovery. This is not something to be ignored. It becomes a critical component. And compliance. And that's something that's better done on-prem rather than in the cloud, in my opinion. So the question becomes, what is the hybrid architecture? And in simple terms, if you need to train large models, train them in the cloud. If you're going to infer, do the inference, do them on-prem, or in some cases, even do them at the edge.
That's excellent. So as a follow-up, you and I were, I don't know, probably two or 3 weeks ago, we were discussing this, and you're talking about the cost of doing some of this on premise now is going to grow significantly and already has. Can you touch upon that a little bit? Just because we need to think about this, not only where we are today, but think 6 months from now, 1 year from now, 18 months from now. Talk about cost.
Yeah. So the current nomenclature around this is two things. Either the cost per wattage, okay, which is the cost, which is an amalgamation of a couple of different factors, but basically, how much does it cost me to actually run these models, whether on site or in the cloud? And the extension to that is now something called token economics. So as the number of tokens is used because you made these different models more available in your organization, the cost to use these models increases exponentially. And so it's the same question from early on in the cloud. This is just simply too expensive. What used to be a couple of $1,000 turned into tens of thousands, hundreds of thousands. And I read about an organization like the other day that thought that it's costing them $100 million to use the model.
Right.
So clearly, this is not something that's got economic long-term viability. Okay. So, question number: what do we absolutely have to use in a hyperscaler? And we have to scratch hyperscaler because there are now neo clouds that are specializing in this, and I include all of them under the cloud umbrella. Even though you can argue that there's differences, and there are. But let's just say off-site versus what you're doing here. And here we have to go into the taxonomy and decide what's the most important part of this. Is it reduced clinician time? Is it automation of workflow? Is it faster diagnosis? Is it reducing errors? Is it performance per watt or cost per instance per model? And that's going to be different depending on what you're trying to do. So right now, in the life sciences side, for example, on the drug discovery side, the consumption has been in the cloud. I suspect that more and more that will be pulled down. In a hospital setting, where a lot of the data is already on site because they control it through their EMR, or it's hosted by the platform, it's probably going to be 50-50 in the cloud versus on site. And again, that marker can move back and forth. But you got to focus. The focus has to be on which one of those things is important to you. Reduce clinician time, automation, faster diagnosis, reduced errors, performance per watt, cost per inference. That has to be undertaken in order to make this a success. So performance per dollar, performance per watt, ultimately.
Yeah, I think this is a really important conversation to have because I've not heard it out in the industry, and you really got to think through this as you're standing up these AI models to really understand what you're trying to achieve. So brings me up to my next point, second to last question here, the ROI conversation. When you're sitting across the table from a CIO or a CFO at a health system, what does the ROI conversation around AI infrastructure actually look like? Like, what metrics are healthcare organizations using to justify the compute investment?
It's not always easy to measure. Yeah. And I bring this up all the time. There are no easy cut and dry metrics that you can point to create the ROI. At this point, it is how has this automation either improved patient experience or improved researcher experience or improved clinician experience versus not having it. And that has a tangible value, but it's not always measurable. Okay. Are we going to have to reduce staff by implementing some of these automated procedures? Possibly, and that's everyone's fear. Everyone's afraid of this. But I think the fear can be exaggerated. Yes, there's going to be changes. Is it going to be wholesale? No. Okay. In my experience, a lot of these models need to be as narrowly focused as possible in order to be effective. And so the wider use of a larger language model is probably not going to be ideal in most settings. Therefore, the real question becomes, will automation make my physicians feel better about what they're doing? Will their experience working for the institution improve? Conversely, will patients have a better experience because they're now using some of the digital interactions in the digital doorway, the digital human interacting with them, being their first line of interaction between the patient and the hospital? Will that improve their experience? Possibly. And in fact, in some cases, dramatically so. That intangible is what has to be looked at right now, because until the workflows are adjusted completely to take this into account, it's going to be really hard to measure the ROI. But everybody is looking at this. Everybody is being forced to evaluate this. So it's not like you can ignore it. Right. You're not good. There is no going back, people. Right. Okay, the train is moving, and no matter what you may think personally, this is going to happen. So the question becomes, how do you make this effective for you? Is there an ROI, a concrete ROI you can point to? In some cases, yes. In most cases, not yet. But there are tangential benefits on the softer side that have to be taken into account.
Absolutely. Here, one last question. I'm looking for like a 1 minute answer because I want you to do a couple of questions. Advice for the room. Let's close with this. If you're a digital health company or a health system leader watching the session today and you want AI analytics that are truly actionable, not just a dashboard that nobody looks at, what's the one thing you'd tell them to get right first? Tony.
Start small. Keep your definition of what it's going to be well bounded. Okay.
Excellent.
Do not try to boil the ocean. Use a smaller set of data and a smaller tangible use case that you can apply. Work with that, refine that. Take those learnings, go on to something else.
Excellent.
If you can do this consistently, you'll have built out 20, 30 different use cases that are effectively using automation through AI to be able to do. And then evaluate. I mean, look, you don't deploy technology in a vacuum. It touches people. It touches process.
Absolutely.
Evaluate those touch points and then go forward. Those are the most successful deployments of this that I've seen, and there are many actually. Use some example of what I just described.
Yep. Excellent, Tony. Appreciate it, my friend. One question just came in. We've got about a minute left to the session. Are LLMs heading to the equivalent of on-prem behind the health system's walls as a means to prevent PHI leakage to the public space? What do you think?
We use LLM language models, and typically they're going to be smaller and defined within the sovereign bounds of your institution. Yes.
Okay.
Absolutely.
Excellent. Probably have time for one more question, Carol, if you have any. If not, we'll let Tony go catch his plane.
Yeah, I mean, just, somebody, if you look at the chat, talking
Yep.
about just an overall discussion as an overriding question about giving consent to their use of their data. I don't know if that's a question that Tony can speak to.
I don't know. Go ahead, Tony.
I didn't hear the question.
Oh, let me see here. If we have a second, do you want to read the question? I'm not seeing.
Yeah, it says in all this discussion has the overriding question of who needs to give their consent for the use of their data. Are health systems actually all healthcare providers obtaining informed consent from their patients? Because people have been able to be identified from de-identified data using multiple de-identification data sets and the use of AI.
I think I understand the question.
Yeah.
So the question becomes, who owns the data? And do I have to get consent to be able to use even a de-identified model? Yes, in some cases.
Yeah,
it depends on who it depends on who they're sharing it with, right? So there's a lot of projects that are going on between research hospitals, academic research centers, and pharmas, where this is being debated right now. So yes, there has to be a better mechanism, because as you rightly noted, de-identified doesn't necessarily mean de-identified. You can break that out. Right. So that is an area of concern, frankly. Not one I'm prepared to answer, because I don't have the answer.
Yeah, well, also, I think the answer's going to vary too. So, no, great. Anything else, Carol?
Nope. I think, Ross, first of all, Tony, thank you for calling in. Ciao. Enjoy the rest of your trip. Just thank you so much. I'm so jealous. I've actually been there before. So lucky you. Thank you, Justin. And Justin, we'll see you later on here in another session.
You got it.
All
Appreciate
right.
it. Thank you. Bye.